Hi guys, today we are going to talk about closures, but before we do that, a short disclaimer or a few prerequisites. This is an intermediate material, so in order to benefit from it in the best way possible, it would be good for you to know what are functions, how are they defined, how are they executed, what does it mean that they are first-class objects, and what are classes, instances, possibly what does dunder call do, and a thing or two about scopes in Python. We'll start in a sort of unorthodox way because we'll start with an example. Let's define a class, we'll call it averager, and it's going to calculate the moving average. So let's define the initializer and then the call method. We can get rid of args and quarks, we will just need a number. We will append the number to our numbers. We'll sum them and then return total divided by the length of such numbers. Let's give it a short docstring as well. Let's write our regular boilerplate thingy down below in the script, and let's instantiate the averager. Let's call it CLS AVG. Now let's give it a try and check if it works as intended. The docstring is there, so that's a good sign already. Now let's invoke the averager. The average of 1 is 1, the average of 1 plus 2 divided by 2 is 1.5, and the average of 1 plus 2 plus 3 divided by 3 is 2. Makes sense. Now, if we inspect the dunderdict attribute of class averager, it won't be anything groundbreaking if I say that we'll have numbers there, and the value of numbers will be the list of 1, 2, and 3. Normally, we would rather access it using the dot notation, so just class averager.numbers, like this. If you are familiar with OOP, then nothing really new. So now let's implement the averager as a function. We'll call it makeAverager, define numbers, and inside we'll define another function which will be called averager. Quite similarly, we will append our new number to numbers. From our averager, we will also return the total divided by length of our numbers. And from the makeAverager, we will return sort of handle to averager. And let's just leave a note that lines below 19, or to be specific from 19 to 22, are local scope of averager function, while lines 16, 17, and 25 are enclosing scope from averager's function's perspective. Okay, now let's instantiate our makeAverager and check if it works as well. Let's use the same examples, 1, 2, and 3. Yeah, looks good. The question is, however, where does this function keep the numbers which it's accumulating in order to count average? In the class implementation, it was fairly easy. It was self.numbers, the attribute of an instance of a class. How about makeAverager? The scope of the makeAverager function does not exist anymore. It was already invoked once, but if we inspect the code attribute and co-varnames, of course, if we do that without the typo, we can see that we get new number and total. And if we take a look at co-freevars, we've got numbers. In the attribute closure, there's a cell object. We don't have to dig deep inside what's the cell. But if we are going to take a look at the first element of the closure and look at its cell contents, it's going to be our numbers list. Numbers is a local variable from the makeAverager point of view. And it's also a free variable from the averager point of view. Right now we can define our closure. Closure is a function which keeps bindings of free variables which exist during closure's definition so that they can be used later on when the defining scope is not available anymore. So as I said, the scope of makeAverager does not exist. However, the instantiated function still has access to the numbers. As you can see, both of the implementations are definitely not optimal because they are using an array of numbers which is growing when passing every number. This is bad both from the computations point of view and from the memory point of view as well. Let's try to improve it. First, let's copy-paste our class. Let's call it averagerv2. What we can notice is we don't actually need to keep all of the numbers in the memory to get the average. What we need is a total and the number of elements we are going to count the average from. So we can get rid of the numbers completely, add new number to the total, remember the number of elements, and increment them when given new number. And then again, return total divided by number of elements. Let's quickly check if it still works. Looks like it does. So we can go to the functional implementation. Once again, copy-paste the whole thing. Let's code make averager v2. Let's get rid of the comments. And we want to do something similar. So we basically want to get rid of numbers completely. Set total and maybe let's call it count. It's going to be shorter. Again, increment the total with the new number and increment count with 1. My IDE already tells me that something is wrong with those total and count. But for now, let's ignore it and let's try to execute the code anyway. Cannot access local variable total where it is not associated with a value. What this means is actually that total is not defined in the scope of averager, because total plus equals new number is basically the same as total equals total plus new number, while the right side of the assignment is going to be evaluated before the left side. The total is actually really not defined, because in the local scope of the averager function, the total does not exist. The same applies for count. Why did it work for the previous implementation though, the one with the numbers? Actually, there is a subtle difference. If we take a closer look, we are defining numbers in the outer function, and in the inner function, we only use method of an already existing object. We use append on the instance of numbers. So we are not redeclaring or redefining numbers. We are already using the existing ones. And as I said, the total plus equals means that we are assigning a new value. In order to let the interpreter know explicitly that we don't want to use the total and count from the local scope, we need to use non-local. So now what it's going to do is going to search for the total and count in the next scope. The scopes follow the LEGB acronym, so the next one after local is going to be enclosing. And as we discussed before, the enclosing scope from the averager's point of view is going to be the scope of the make averager v2. So the total and count are going to be taken from there, from lines 50 and 51. And now again it works as expected. Hopefully I made the closures a little bit more clear for you, and hopefully you can use this knowledge to learn about decorators and more advanced stuff in Python. Thank you for your attention, and see you later, guys.